I'm going to do my homework.
Oh, this
turn in for half points. I have.
Yeah, I was so.
Oh, that's interesting. Okay. 5.3, day one. What's wrong tomorrow?
Should I not come to school tomorrow?
Oh, you'll
Is
just
something tomorrow?
always.
You think I'm learning on my own?
Maybe. Okay. Are we ready? Oh, I thought I paused this, but we didn't. Okay, you guys, we are going to do properties of definite, these are called definite integrals. When you have an integral that looks like this, a to b of f of x dx, we know this means find the area from a to b. That's little s of summing up all the rectangles. This is called a definite integral when I have numbers on the a and b. I'll have to fix that. When you don't have the numbers, it's called an indefinite integral. Okay, let's see if that works. We are also going to do the average value of a function. We've done average rate of change. An average value of a function, you can easily get confused one for the other. So you have to read carefully. And then we're going to do the mean value theorem for integrals. It's not really a difficult section, but it's kind of dry as we go through it. Okay, class opener. How do those integrals relate? Well, if you don't know, I'm going to draw a picture. Because I'd like you to know why, because if you know why, you remember them. So this is the area from B to A. So here's f of x. They're not quite the same. Here's A and here's B. Think of this as a vector. I want this area right in here. But what's it doing when I go from B to A? What's it doing? Where am I starting? I'm starting at what? At B. So I'm going to go this direction. So when I divide this up into rectangles, the base is called delta x. Right? What's going to be true about my change in x as I go to the left? It's negative. So it has a direction to it. What's true about the y-coordinate here? Remember, that's the height of my rectangle. F of x equals the height. And what's true about the height? It's positive, right? What happens if you multiply a negative and a positive? You get a negative. And when I get to the fundamental theorem of calculus, this will make even more sense. So what's the integral from b to a? How does that relate as opposed to, going from a to b? No one always says that. Just, it'll be back. But how does this relate? Delta x is positive. The y value is still positive. So the integral from b to a, how does that relate? A to b. They're negatives, opposites of each other, because of the direction. If you can't see, please remind me to slide the board. Is that okay? What if my graph were under the curve? Why is this integral negative? It is. Here's A, here's B. Right. Because what's true about f of x? F of x is less than 0, and if I'm going from A to B, delta x is positive. That's why that's negative. So it's a directed distance, if you want to think of it that way. So this integral from A to B, this particular case, is less than 0. And some of you may notice I keep writing these little dx's, but that's delta x. That's your base of your rectangle, and there's your height of your rectangle. So it's really important to put that little differential in there. If you remember, we called that differentials. On the exam, I really don't want to tell you this, but on the exam, if you don't put the differential in, there's no penalty. The penalty will be that you'll probably mess up doing the problem because you have to really think about those differentials because they are important. Height. Thank you. You guys have all your texting deals. I have my math. Height. She's back good. Okay. So, what about this last integral? Yeah?
Should we draw that second one?
That's up to you. It's up to you in your notes. Now, I put this up, and I'm thinking about switching over to PDF files, because then you can just open any smartboard. Nice thing about a smartboard, if you go in there, you can actually move things around. Where if I do a PDF, it's just what it is. But it doesn't matter to me. I'll see how long it takes me.
PDFs work better on Macs.
My smartphone works fine on the Mac.
Don't work.
Really? I don't know why either. Okay, what about the integral from A to A? That's the area from A to A. It's 0. Because what's delta x there? The height, you certainly have a height, but what's the width? It's 0. Okay, so that makes sense. If it makes sense, then you'll remember. And the rest of these things, we're going to try and make sense out of them as well. Okay, we're going to do all these properties of integrals. There are 7 of them. You will come by them naturally. And you don't have this written down on your sheet, so we're going to have you write it down, and I'll do some pictures too.
Wait, are these rules for anti-differentiation?
It's rules for definite integrals, not the rules for anti-differentiation.
Right in the back.
It's on the very front page. Did she call it?
No, that's anti.
Yeah, it should be for definite integrals. She just changed this so she wants you guys more involved rather than me just saying this is what it is. I don't have them memorized. I don't know what they are. I just use them. I say, yeah, I can do that. So the first one, oh, we already did that. The integral from B to A is the opposite of A to B. Okay? And I wouldn't even, it's up to you if you want to write the words, but basically this is the property I need to know. What do you think the next property is? Integral from A to A. Yep, that's 0. And those are definitions. You can't say, why is this what it is? But I can justify it with a picture and have you at least believe that it's true. And you're going to have, if you turn the page, you have 2 of them on the back. So you need the first 5 on the front page. And there's a back page, too, that you can write on the back if you run out of room. The maximum inequality. Okay, ready? Okay. Now, what this is saying is that if I have a constant times my function, right here, I can pull the constant out. And you remember when we did derivatives, like the derivative with respect to x of 3x to the 4th. Remember, we pulled the constant out. Well, we just went right to the answer, but we could have written it this way. d dx of x to the 4th. And what's the derivative of x to the 4th? 4x cubed. So the answer would be 12x cubed. So when I do these integrals, I can pull that constant right out in front and ignore it. You're going to want to do that. You may not have done it here, but when you do the integrals, you're going to want to do that. It's going to make life a lot easier. No, it's just k. Right? K is just a number. And you know why we don't have to use the product rule in this? K is a constant. So if you did this, you'd have to do plus. Then it would be x to the 4th times the derivative of that constant. The derivative of 3 is what? 0. That's why you don't have to use the product rule, and you're able to pull that constant out. And since this is an inverse operation, it's similar. Okay? There's just an example. You can pull the negative one out. I'm not going to worry about it. Okay, if you have the integral of 2 functions being added, you can break them into the integral of the first function plus the integral of the second. Added or subtracted, we're okay. Either way works. So you're distributing the integral, if you want to think of it that way. And then you're tempted, at least I'm tempted. If you have f times g, you want to make that the integral of f times the integral of g, but guess what? You can't do it. Is there a product rule? Well, there's kind of a product rule. We'll have to figure out how to handle product rules. It's not easy. It's not, taking derivatives is much easier. I can always take a derivative. I can't always do these integrals, which is unfortunate. So you can distribute over addition, subtraction, but not over multiplication or division. Okay? So I don't know if I even want to write that down. Some of you will try it, and they'll say, no, you can't do that. So don't try it. And then this is the additive property of integrals. And I like to look at pictures. I mean, maybe I could figure that out without a picture, but I like to look at pictures because it helps me. Isn't it? So I'm going to draw that picture. So this is saying I want the area from A to B. So here's my function. And here's A, and here's B. That's what an integral is. It's the signed area. I want that. And I want to add the area from B to C. So you don't have to do it this way. You could just say, well, we're going to start at A and end at C, as long as they're right next to each other. If there's a break, if you have a rectangle or an area in between there, then you can't do that. But that's just saying, if you want to find the area from A to B, and then the area from B to C, I can just do A to C. But you're just going to do that naturally. Sometimes you want to go backwards. Sometimes you want the area from A to C, but you're going to have to do the integral from A to B and then B to C. Depends on the picture. If you can use geometry, use geometry. I don't want to use calculus unless I have to. Okay, is that okay? Those seem pretty common sense. Okay, the next one. Let me turn your page. That's the max-min inequality. And that looks really weird. So I'm going to go ahead and draw a picture of this. It's the max-min inequality. I don't have enough room. Because when you look at the symbols, it's kind of scary. So instead, I'm going to try and understand what's happening. So I have some function. There's A, and there's B. And it slows me down too, which is good. Now, on this closed interval, this is the minimum value, right? And this would be the what? Max. Okay, so that's capital M for max. And this is little m for min. And all it's saying is if I want the actual area under the curve from A to B, the signed area of that function, that's trapped between the area of this rectangle and what's the area of that rectangle? Yeah, it's the minimum value times B minus A. So this is bigger than the minimum times B minus A. And how does it compare to this one? This area, how does that compare to my integral? Because remember, the integral is just right under this curve here. There's the integral. It's bigger. And that's all it's saying, that I'm going to be trapped between the maximum value of the function The area will be trapped to the maximum value of the function times the width of the interval and the minimum value of the function. Those are just areas. That's what that theorem says. So if you would just look at that without the picture, it may not make sense. But now when I look at it this way, looks better, right? We're gonna use it in the mean value theorem in a moment, which I could go to, but we'll come back to that. It's just, they could ask you between what values is this integral between. So they could ask you that on the exam. So you'd have to find the minimum value and find the area here, find the maximum. So I know that my area is going to be, if this is 2 and this is 3, let's make this one 5. So the actual integral is going to be between, well, what's the area of this little rectangle then? If that's 2 and that's 3, that's 6. And the biggest area it could possibly be would be 15. You could, on a multiple choice question, say, what intervals would this area be between? I can't say I've seen that question because I don't see every multiple choice exam. Okay. You're not allowed to tell me. So that says max of f and minimum of f. So looking at that by itself is kind of scary looking. Then the last one is, oh, I had my picture there. Oops, I forgot I'd done that. That's okay. This domination, I don't know why it's called domination, but anyway. Don't even go there. Okay. If f is bigger than g, so I'm going to draw a picture.
Your favorite?
If f is bigger than g, there's f, and there's g of x. This makes total sense if you think about it. And it says the area from a to b of f of x, that integral, there's a, that's b, and they're saying that this integral is bigger than the integral of g. Are you're going to think about these theorems? No, you're just going to look at it and say, obviously the area under f is bigger than the area under g.
Should I write all that?
That's up to you. They're your notes. Now, when you go to college, you're not going to be given the notes like we give you, so you're going to have to figure that out.
What does this arrow mean? Is that
Yeah, this thing, oops, it means implies. Mathematicians have lots of different symbols.
It's like texting.
That's right, just like texting, but for math. And they're saying, what if my function is always positive? Here, this function's always positive. I'll use this picture anyway. What's true about the integral? If the function's always positive, it's positive. You can't say anything about, I did leave myself space there, but you can't say anything about if some of it does this and some of it does that, and you're left with maybe this. Some's positive, some's negative. I don't know, unless I do the calculations. But if the function is always positive, the integral is going to be positive. Okay. Some fun. We're going to do some problems here. Now, these are integrals, areas. We're going to use tables. And by the way, this is exactly what the homework looks like. The first few problems are just like this. So if I try to do A, I'm going to let you guys work these. We'll do A together. What's wrong with this? It says 4 to 1. I have negative 1 to 1. I have 1 to 4. So
it's going to be negative.
It's 1 to 4 of f of x dx is the opposite of 4 to 1. Now, there's no work to show on this one. We have to talk about homework because we have to learn how to show homework correctly. If you don't know if your homework is done correctly, then do look at the answers online. Now, don't be like BC Cal because they just copy the answers online. That's silly because that doesn't do any good, right? Yes, but I'd like you to check your answers. And if you have no work and there's work on the answer sheet, that means you need to show some work. And when you go to college, they're going to do that. They weren't supposed to use a calculator. You have to be able to do it by hand.
What if you have beautiful mind?
Doesn't matter. They don't care at the University of Minnesota. If you don't show your work, you don't get the points. And they do collect homework. At the University of Minnesota, they do. I worked there. I graded homework. Okay. And it wasn't my choice to grade homework. That was part of the job. Okay. So what is this area? This is -2, right? So what's the answer? This is +2. Now, I will warn you that some of these can't be done. Okay, so try it. B isn't too hard. I know what C is, I think. Now, I can't do these in my head. Well, I can do B in my head. And what's the answer to B? What's the answer? No, you need to show your work. Because if you just give me an answer without any work on the exam, you will not get any points. Even if you're saying, oh, I could do that in my head. They don't care. Okay, so I want -1 to 4. So I have to do -1 to 1. That's that additive property. Plus 1 to 4. So it's 5 plus a -2, which is 3. Try C. Adam, try C. You have to pull the constant out. Pull the constant out. I'll show you how to do the other stuff on that. What'd you get for C? Try C. 31, yeah. You can't do those, can you? What happens on D, E, and F? Why can't you do it? Outside of the domain. We don't have enough information. They do that on the exam, but it's usually like the last point. Sometimes they can do that. I've seen it in BC. The red. Not enough information. Okay, so to do C, I'm going to do twice the integral from -1 to 1 of F plus 3 times the integral of -1 to 1 of H. What's F from -1 to 1? 5. There's my plan, but minimally I need to see this line that I'm working on right now. Plus 3 times H. From -1 to 1, I'm fine. That's 7. So you get what? And I don't care about the arithmetic. You don't have to show me the in-between steps. The answer is 31. Now, how about F? Can I do -1 to 4 on F? Yeah, we just did it. We did it right here. I don't want to read. This is 3. But what about -1 to 4 of H? We only have -1 to 1. We don't have enough information. And yes, they could do that on the exam, give you a situation and say, find this answer if you're able to. If not, tell us why not. And all you say is there's not enough information. So it's not that bad. So the first part of the homework questions are just like this. Is this easy? Hard? Natalie, is it okay?
I'm
just going to break these up. Yeah.
I don't want to ask you.
Okay, you want to ask me later then?
No, okay. Okay, so what are the steps? No, go back.
I could have done that, but anyway. Oh, that's not that bad to do.
All right, so on A,
Mm-hmm.
saying,
It's 4 to 1, but I know 1 to 4. So this has
is
to...
that one property so you put a negative sign?
I did.
Whatever the other one is. So.
This was -2, so I made it
you're
positive
saying
2.
it's 2. I thought you said the answer was negative. That's how it's
No. Sorry. That's not a dumb question. And actually, we could do that.
No, it's not.
Let's do average value because that's important. It's very important. This is going to be on the exam. If you've looked at the salmon-colored packet, you will have seen average value asked at least one place. So, how do you average numbers? Okay, so you add them up and divide by the total number of numbers. Now, this would be like 2, 3. What should you have? What doesn't matter. Those are discrete values. So we would add them up. And if you were asked to do this on a test, I would want to see where you're adding up. I know you can do it in your head. And you would divide by what? 4. So you get 5. I don't like to put the equals in. It's not an equation. I just evaluate it. But what if you're talking about a function? It's continuous. This is discrete. These are, you can count these. What if you have a continuous list of numbers? Okay, Zach. What are we going to do if we have a continuous list of numbers? I could do it with limits. I'm going to keep it simpler. If I want, here's my function, f of x, and I want to find all the sum of all the average of the y values from A to B. I want to average the y values there. You would add them all up. If I added up all these y values, how could I write that with calculus?
The thing
Yeah, it's the integral. It's adding up all the y values from A to B. Now, is that the average or is that just the sum? Now, you have to divide by how many numbers you have. And unfortunately, there's an infinite number of numbers, but I want all the numbers from A to B. So how could I write that? B minus A. If you can remember that, that's one less formula for you to remember. So to do the average value of the function, you add up all the y values and divide by the width of the interval. And you know what? You know that that has to be between this area. Should have made it a little steeper, but I didn't. I'm not sure I understand your question. And that area.
Couldn't we always go A to
Mine went A to B. Left to right. Okay, guys? Isn't my area trapped between these two? Do you agree? This is the minimum one. That's the maximum. Isn't my area somewhere between that? Okay, so let's call this place where I have the average, let's call that C. Okay, guys? Somewhere in between there, I know my area is between, guys. And I know it's not fun to write all those little symbols out, but if you don't, I'm part of a listserv. If you don't, they don't give you full points. You have to write it out mathematically correct. Okay? I know my area is trapped between there. But you know what? Someplace there has to be one rectangle that's equal to the integral. Does that make sense? This is going to pick up an area of whatever it was and get up to the big number, but somewhere in between there, it's exactly equal to that. So this, what's the height of this rectangle here? Of my green one. This is C. What's the height? F of C. I'm saying that the area is going to be trapped between the minimum value of the function and the max times that width. That means somewhere, if this is 10 and that's 20, my average area has to be somewhere between 10 and 20. So it's F of C times the width of that interval, B minus A, is exactly equal to this, provided it's a continuous function. If it's not continuous, all bets are off. Well, guess what this is? If I take this and I multiply both sides by B minus A, I'm going to get the integral from A to B of f of x dx equals f average, or f of c, times b minus a. It's just a different version of the mean value theorem, because that's what it is. That's the mean value theorem for integrals. Is it related to the mean value theorem for derivatives? Yes, but I'm not ready to, you're not ready to see that relationship yet.
That was like
Well, no, because you have to have the fundamental theorem of calculus to do it. Then it's really cool. I will connect velocity, position, all that stuff. All that will be connected both with derivatives and antiderivatives. Okay, yeah, let's do an example. Okay, there it is. Okay, guys, shh. This is average value of a function. What is the average rate of change? Okay, guys? Cole, what's the average rate of change? This is the average value. It's called a mean. Average and means are the same thing. It's the average value of the function. This is the average rate of change. What is rate of change? It's slope. So do you remember how to find the average between two endpoints? Change in y. I don't want the instantaneous. I want the average over the change in x. Or you can write it f of b minus f of a over b minus a. It is related to that mean value theorem. And do you remember the mean value theorem for derivatives? Bet you don't.
I do.
Do you?
Yeah. It's like
Here is the average rate of change, right? And I'm just going to move this over here. Someplace, the instantaneous has to equal the average. That's the mean value theorem for derivatives. Is it coming back now? There aren't very many theorems, but these are the important ones you have to know. The other one's intermediate value theorem. So this is saying f prime of c has to equal f of b minus f of a over b minus a. Don't make this hard. Wait a minute, don't make it hard. I want the average value of this. So what do you have to do? About the average value, what does it tell you to do? What do you do first? Integrate. Find the integral. So we're going to integrate, find the integral of 4 minus x squared. That's the height of my little rectangles. This is the base from where to where? 0 to 3. And what I always forget to do when I find average value is I forget to divide by the width of the interval. By the way, you get a point for just recognizing this average value if you get the width of the interval right, generally speaking. This is over 3 minus 0. Now, think about this. I want the average y value of that parabola. What does this thing look like? Looks like this, right? So, can it be, well, what's the biggest y value I get here? 4, right? This is at 4, and then what happens down here? At 3, I go down to what? Because I know what 4 minus x squared looks like. And then I substitute 3 in here. 4 minus 9 is negative 5. So my average value has to be what? Can it be 10? I'm averaging the y values. You're averaging each one of those each one of those little dots along there. It's got to be between 4 and negative 5, so I know if I did it right or wrong. Now, you don't know how to integrate that. So I'm going to have to bring up my calculator. We will. Guess what? You're learning tomorrow.
No way.
You'll miss something really, really important. And then we'll figure out how to do a definite integral using integration, techniques of integration. And that's called the fundamental theorem of calculus. No, that's from BC Calc. It's a parametric curve. It is not a function. But we can find derivatives and we can do all that stuff on that. But we don't want to be in that mode, so let's change it. Next year, come back for BC. And it's easier to do Calc 2 here than it is at college. So even though you may not want to work hard next year, it's easier to do it here. Okay, so do you want me to do it on the graph? Do you want to see it? Now, the graph won't give me the average value. It'll just give me the area. And I like to zoom at 4. Oh, that's not going to work. Well, it's almost, I really want 0 to 3. So let's make this 0 and make that 3. And we know we had to go down to negative 5, right? Not small enough. Negative 5. Oh, I forgot to make my window big enough. Whoops. And it's 4. I did the wrong one, yeah.
Better traps.
It's okay to go there, but I need this one to be 4. Okay. And we want to integrate, so we go second, calculate, 7. Says find the area under that. We're going to start at 0, and we're going to go to 3. Now it's actually easier on the Inspire, but that's okay. That's what we want. So all the y values add up to 3. Remember, some of these are being offset by the negatives. I was doing it another way too. And so what do we have to do with this? We take this 3 and divide by 3, so the answer is 1. Does that make sense? My numbers had to be between 4 and negative 5. If I got 10, I was in trouble, right? Can't happen. Then I start over. So how do I do it if I don't want to look at the graph? Because if I do the graph, I have to have the right window. Do you remember how to do that? You go under Math, and it's 9. That's right. So if you run into any of these things right now, you're just going to use your calculator if it's something you can't do with geometry. And I want to go 0 to 3, and I want my y value, which is in bars, unless you have the nice new version, which you should get, because then you can do it this way. It's just much easier. And then you go over here and you put in your x. And I can write down what it looks like on the old version. And now we want to divide this by 3. So if I press divided by 3, I'll get my average value. Now you could program, you could not program, but put in your calculator, because I'm not going to clear your calculator, some of those special formulas all at the end. Just turn them all off. Because you have y1 all the way through y10. And then you don't have to remember it, but there it is. It's 1. So what does it look like if you have the old version? It looks like, I think, FNINT, and then it's y1, comma x. You have to say what's the variable, because when you get into further math, if you choose to take that after BC or concurrently with BC, you're going to be working with more than one variable, multivariable calculus. And then you want to go A to B. So that's 0, that's 3. Because you can integrate x and y together. Trust me, it's not that bad. Okay, mean value theorem for definite intervals. This is in the way.
4 minutes.
Always assume it's an average value at least once in the interval. Now there's the assignment. Don't forget to do the quick review. And those are the problems. It's not that bad of an assignment. Now, we have a little more time than we did earlier, second hour. Should we look at some of those salmon problems?
Yeah.
And by the way, now you can do some of them that we couldn't give you before. I need to pack it though.
I can go for a nice.
So now you can do 6B as in boy.
Go for it.
This is asking for the average value. So in 6B, it says use the trapezoidal sum to find the average number of people waiting in line during the first 4 hours. So it's 0 to 4 of L of t. dt. I want the average value. So you know what you're going to do? You're going to find the area using trapezoids and divide by the width of the interval. So you could have done 6B, you just didn't know what average value was. You just have to integrate it. So you can do that one now. And I think there are other ones that ask you for average value in this packet, but I'm not sure. So tell me where your questions are.
Can we just do the first one?
Okay, it says use a midpoint Riemann sum with 4 subintervals. So this is number 1. I should make this into a smartboard. Maybe I do have it. I don't know. I'm not going to put the y values in. Now, not always are the t values nice and easy, but these are. Oh, yeah. And you have the answers to these online. They're all there. You can always go to the website. You can't go too far back, as far back as we go, because I think it's only 2004. All these are on there. Go to AP Central. Just Google AP Central and you go there. You can see the exam questions and the solutions. Just go directly to the solutions. Okay, use a midpoint Riemann sum with 4 intervals of equal length to approximate the interval from 0, does that say 40 or 60? What does that say? Thank you. 0 to 40. I want 4 rectangles. I don't want to graph this, but you can. Here's 1 rectangle, 2, 5, 10, I missed some. 15, 20, 25, 30, 35, 40. Pardon? Yeah, I know, it says 4. 1, 2, 3. Doesn't say 4? Down to 20. Oh, that's what I did wrong. Let's undo that. Okay, 0 to 10. There's your midpoint. And then you go 10 to 20. There's your midpoint. Then you go 20 to 30. There's your midpoint. And 30 to 40. There's your midpoint. What's true about the base? What's true about the base? Oh, they're 10. They're all the same, which is nice. They're not always the same. So it's 10 times, and then I need these values right here. Yeah, let's do that. And by the way, that's good to get you 1 point. And I can bring this up and we can look at the points. I don't know what the answer is, though, because I don't have answers in front of me. Okay, based on the table of values, what is the smallest number of instances at which acceleration could equal 0? From 0 to 40. This is the velocity. That's V. I called it L. Can't even read it. Yeah, I chose not to wear my glasses. So, if you graph it, that's looking at the slope of this, right? Did you try B? We didn't assign B, did we? But C, what did you guys do on C?
No, I didn't try it.
Okay, let's look at it. Because I want you to get over your phobia from looking at these things. It says the function is this weird-looking thing. I think that's 7t over 40. Make sure your mode is in radian mode, always. And it says we're going to use that to model the velocity of the plane. So this really is v of t. You can't omit any words. And according to this model, what is the acceleration at t equals 23? Do you remember how to find the acceleration? It's the derivative. Are you going to do this by hand?
No.
No. T equals 23. If you're not in radian mode, you will not get the right answer. So always in radian mode. N derive of my v of t, comma. Now I'm going to do x's on my calculator, but the variable in question is t, and then you're going to put in 23. I would put this into y1, because otherwise there's way too many parentheses. Do you want me to do that, or are you going to do it? You guys can do that.
I'm going to roll back now, so I don't want to stop.
And on D, now we can do D on number 1. And you can actually do B. I'll let you think about B. According to the model, what is the average velocity of the plane? Keep in mind, you have to look carefully at what you're given. These are velocities. I want the average velocity. Is that the average rate of change, or is that the average value of the function? It's average value. So on D, and actually it's of this function, according to the model on F, I'm going to integrate this v of t, or f of t, whatever I have here, that was n derived, from 0 to 40, and then we're going to do what? If it's average value, what are you going to do?
We're going to do 40 minus 0.
40 minus 0. So that's the FNINT. Now, until last year, and that's going to be e of t, comma t, comma 0, comma 40. Until last year, the first 3 questions were calculator problems. Last year, they changed it, only the first 2. So you have to look at the problem number, it's 3. So it is a calculator problem. Oh,
Calculator during the first 3 questions?
yes, but not this year. First 2. By 40.
Yeah.
Pardon? Artavan.
Yeah.
Yeah, if you put it in Y.
Yeah.
Yeah, don't forget to do that. So look through all of these as well and do more if you can do more. I don't know, let me see.
Enter this in my calculator.
Oh, you have to have more. Oh, now pull that back out. Then you have to say comma. Where's comma? I'm on 3 different calculators, so that's always, and they move it with an X, comma, and we want to do it at 23. You have to tell it where.
Yep.
Now it should work.
There we are.
Okay. So if you stand back, I know it's kind of scary looking, but when you look at this, and you get into it, it's not that bad. How many points do you need?
5.
5 or 6? So try that. You want me to bring up the answer key so you can score it? Adam, you haven't done it.
I did it.
Now, it's in Schoology, but it's also in here. You did all the parts?
You face
A, C,
We'll do them all. Okay, this is 2004B. Now, how long should you spend on any one problem? 15 minutes.
That's like 180.
You might not get it all done.
Think time
But what you're this is number 3.
Well, how do you
580.
know?
Like extended time.
What?
Okay, there it
Like an
is.
extended time if I need.
Did you get 2? Now,
I have 17 for this.
you'll get 1 point for writing this up. 1 point for the answer, by the way, that's here. And what did I forget to do? I forgot to do something. Whoops. It says using correct units, explain the meaning. What is this? If you add up all the velocity times times, you found the what? Total displacement.
Yes.
I believe it would be okay. They're okay with total distance because it's positive. If it got negative, then we'd be in trouble. So it's a total displacement between t equals 0 and t equals 40. You have to give the time. And my units were in feet, right? Oh, miles. Sorry. The integral gives the total distance in miles. The plane flies during the first 40 minutes. You have to have all of that. You can't just have some of it. Okay, Julian, did you get that? You have to have all of that to get that point. So you might only get these points. You might not get that point. Okay? Now,
Calculator ones, you have to take that.
no, you may leave it like that. But you must put in the values. Okay, guys, the question is, do I have to add that up and get 229? No. But you must put in the values. I'll do that at least. I'll let you think about B, even with the answer. That, I think, is the toughest part of the problem. Here's what you should have gotten for C. The derivative is negative 4.07. You guys, Matt, I don't think you got that.
What? Yeah, no, I
Typed it in wrong?
I caught him on that mistake.
When you enter them into the calculator, double check.
Yeah, I got mine and like printed
Yeah, the 7 is faded.
Okay, average velocity, look at this. You get 1 point for knowing it's the integral from 0 to 40. 1 point, pardon? Because it's the average velocity, so you have to divide by the width of the interval. And the other point is for adding the 1 over, really, it doesn't look like it's that at all. It's 1 point for doing the integral, and 1 point for your answer. So you should have 3, 4, and let's say you can do this right, 6. It's not bad, is it? Almost time. Who's not here? And who? Oh, I think Adam's here.
I wish Adam Duck was in here. That'd be nice.